Hello everyone, welcome to your next chapter and section. In this chapter, we're going to learn a little bit more about, statistics and data frames and how to take an Excel file or a CSV file and run basic mathematical operations and statistics on it. So half of your class is going to be learning about this package called Pandas, which is used for, CSV and data manipulation and analysis. We're going to learn about a data frame object, which is this is going to be similar kind of stuff that you'll learn in other languages when you're dealing with, files of data that you need to process. So a lot of the things that you'll learn from this are extendable to other languages because we kind of use similar tricks because they seem to make the most sense to data scientists at the moment. So I'm hoping by the end of this chapter, you're going to learn a little bit about statistics and how to manipulate data frames and pandas. Pandas is super useful for jobs. You're going to see a lot of jobs saying you need to have some familiar with pandas if it's working with Python and data science. So it's definitely a skill that is going to be useful for you in the future. So what are you going to learn? We're going to learn how to import our pandas functions. We're going to play with, remember how we installed pandas last chapter using pip? If you haven't done that, please do that. We are then going to play with pandas data frames for a little bit. I'm going to show you how to load in some data. I'm going to show you how to create a basic data frame and then, do some basic manipulation, indexing, and all that kind of stuff. So data frame, what is a data frame? It's an object in Python that it's basically like an Excel table. It has rows and columns that you can access using specific commands and do very, similar kind of like Cody related Excel type logic and operators on it if you'd like. You can do for loops on them and you can do, basically anything that we've learned from Python previously up until now can be applied to a pandas data frame object. So with that, guys, let's move into our syntax where we're going to play a little bit with pandas data frames. I'm going to talk to you about how indexing and slicing works. Okay, as you see here, our first line is our import function, or import command. Remember, we learned about this last chapter. In order to import something, we simply say import, and we figure out what the name of the package is in Python. You can go to help, and that module's spam command can help you with that, or the documentation from the website that you downloaded some new function from, or library from. It'll usually tell you what it's labeled as in the documentation somewhere. Lastly, we're renaming this as PD, so we don't have to write pandas every time we want to call a pandas function. It's just easier to type 2 letters than it is to type 6 here. And that's just a common thing that a lot of people do with pandas is they just call it PD. Okay, so this next line is how we create a data frame. We're creating a data frame called df. We are using the assignment operator here, and here is the command we're using to load in data using pandas. We're specifically going to load in a CSV file that I'm providing to you guys. Very simple data. It's only 7 rows. Make sure you save that file in your Udemy Python script folder, okay? In this example, I'm assuming that you're already in Python in that folder directory, but I'm going to show you how to do that even if you're not. So this is how we load in some data here. We just go, read CSV, and we give it the name of the file that we're reading in, and I'm calling it test data here. This next line talks about how to index specific rows. So what this line says is, remember that when we index, we start from 0 in Python. So the first row is 0. So this is saying I want all columns for rows 1 to up to 3. So this will go 1 to 2 here. And it'll give all of the column information for those rows. Okay. If we wanted to give specific columns, let's say there are a dozen columns and we don't want all that information, how do we go about doing that? We would use the .lock function. That is a function that you can use on a pandas data frame if you go into the help menu and look at the object or the documentation around that. So what we do is this is separated by a comma. So the first set of values are the rows that we want. We can ask for 1 row, multiple rows, exclude certain rows, you name it. And then we provide the columns that we want. I'm only asking for one column in this example, but I will show you how to access multiple columns in the next section once we start playing with Pandas. So the syntax for finding a row, specific rows and specific columns in Pandas is using the dot location function, using square brackets after location, providing the rows that we want using the index methods that we're already familiar with, and providing the columns that we want after the comma, okay? So last but certainly not least, let's say you want to do a for loop. You want to iterate across these rows and do some nifty calculations. You know, maybe throw an if statement in there that's like, okay, if this value is above, 32, run some other operation than if it's below 32. Let's say there's an age column, so you want to look at like the differences between people above 30 or under 30, and you could like have different math for older people than younger people or something like that. So the next thing in order to do that is using the .iterRows function here. Okay, so what that function does is it creates a list of lists. So at first there's one list, and every list within that list, every element is basically a row of data. Get 1, 3, 5. Let's say there was like columns, column 1, column A, B, C. So this first row, what it'll do is it'll give you an index value, so the first what row number it is, and then this list of values which represent all of the values in that specific row. So this df.iterRows is clearly creating a list because we can do a for loop on it. And it also is stopped here with colon. And then everything that happens afterwards, of course, is what we do to that each element, each list in that embedded list of data. Okay, guys, so let's hop into Python now and see what we got going on there and play with this a little bit more. So here we are here, guys. Welcome. So first thing we need to do is import pandas. So we're going to import pandas. That's the syntax for this. We usually import at the beginning when we're first building our scripts because we want to use those functions later on. So we're going to import pandas as PD, and now it takes a little bit of a moment to load. Now if we go .pd, we go pd dot, and then press tab. It's going to tell you all the different functions that are available within Pandas. We're going to work with the read CSV function right here. So we're going to go read CSV, and you might not have seen it, but I'm actually still in my root directory here. So even though I'm supposed to go test data.csv, it's not going to work. Why? Because it can't find the file. It's not in that folder. So in order to get to that folder, in my case, it was in I made my Udemy Python scripts folder in my desktop folder. I go desktop / Udemy Python scripts / and look at that. It actually does load a data frame. This is the output. There was no error. But I didn't save that to a variable. So let's go back up here and go df equals. And now we have a Python or Pandas data frame stored as df. That does exist now. So with that, let's start playing a little bit with manipulating this data frame. First, let's start with our first indexing method, which is just getting specific rows that gets the first and up to the third, so the first and second rows here. And that's what we looked at before. This is very similar to how you would do something like this for a list or a string. You'll also notice that here are the columns for this data frame. So we can access, column information for name, age, or weight, and this is saying that there are 7 rows. This 0 to 6 is like the index position for each of these rows. So what happens if we want just the name and weight of this data frame for for these 3 rows, or these 2 rows rather. So we use that .location function where we first pass in the rows that we want to give it. We're saying 1 to 3. We then separate that with a comma to say now we want to tell you what columns we want to give it, and that works like that there. So you also notice that using the .location function, this doesn't go up to 3. It just says I want positions 1 to 3. Okay, so that's an important thing to consider there. The next thing we want to check is what if we want multiple columns, okay? If we want multiple columns, we have to wrap our column variable here in a list and provide each of the all the columns that we want in that list as the next element of dot location. What happens when we do that? Okay, so you notice that age returns some weird information. So NaN. What this means in Python or in Pandas is that this is not a number. Effectively, this means that this cell is empty. If it was an Excel sheet, for instance, that's Pandas' way of saying this is an empty thing. Why didn't this work? We have age here. Well, it's because it's case sensitive. I had a lowercase a, and this is definitely an uppercase A. So now the numbers come in fine. So I wanted to show you basically how that all works, because the case sensitivity is important, and knowing what NaN means is also important. Lastly, let's see what happens when we iterate across this data frame. So we had to put in, when we do the iter rows function in for a for loop, we have to provide the index and value. If you look at the documentation, it'll definitely say that. Index is going to tell you what the index position is of your row, and the value is going to tell you all this information here, 1, 2, 3, as a list. So value is going to come in as an embedded list, and each iteration is one list with all of the value, all the information in it. So df for index and value in df.iterRows : now remember, our for loop syntax is for, the variables in our iteration, in the object we are iterating across. Now what we're going to do is we're going to print the index, but we're also going to print the value, and you're just going to see what comes out of this, and I'll explain it. So first off, the index position is printed here, and then we have name, age, weight kind of presented horizontally, and then it says data type object. Okay, so what this is doing is it's printing our index, but it's also printing like a pandas data type that is all of this row of information. So if we wanted to just like get this information as a list, we can force list information on, or force this type into a list using the list function. So if we go print index and then list of value, what do we get? Well, this is a lot more easy to read, and now we can actually start to think about how we can do operations with this, with the knowledge that we've gained from chapters 1 to 4. Okay, so with that, guys, I think we should end it here, because now that we have access to information in this pandas data frame, we can actually do things with it, which I want to save for our next section. This was good to get to for now. So what did we learn today, guys? First, we learned how to import pandas and make that package like work. We learned how to import data, like load some data in and do some basic manipulations with it, where we are asking for row location indexes as well as row and column. And lastly, we learned how to iterate across all rows, so we can do some fancy, conditional statements or analysis later down the line. In our next section, we're going to spend a lot more time with pandas data frames. It's a two-parter, so we're going to learn a little bit more in terms of advanced functions and some of the other nifty things we can do in pandas. So with that in mind, guys, catch you later. Hello everyone, welcome to your next section. Today we are going to extend upon our knowledge of pandas by using a couple of more functions and commands. The last section you learned how to do basic indexing and some basic loading and manipulation. So today I'm going to show you more advanced features of how to index, how to extract only columns or rows that have specific values or that have some sort of conditional statement that you can input into them to make sure that the values are what you want them to be, or be like very specific in selection of values from rows and columns. We're going to show you how to manipulate data frames a little bit more by appending to the end of a data frame, concatenating two data frames together, and then we're going to show you how to eventually dump all of this information into a CSV file. So this is really to try and complete a general basic understanding of how to manipulate pandas data frames so that you can then go on and start to look at this yourself. In our next section, we're going to be talking a lot about statistics. So having this good foundational knowledge of data frames in pandas will make it a lot easier for you to run the statistics that you're going to be running later in this section. So without further ado, guys, what we're going to learn today is we're going to learn how to replace data in our data frame. So we have a value and we want to change the value. We're going to learn how to append to the end of our data frame by adding a row or two. We're going to learn concatenation, which is essentially like merging two data frames together. We're going to learn how to select values, rows and columns in a data frame based on very specific conditions. And then lastly, we're going to try and dump this into a CSV file. Okay, so for definitions today, I mean, all you're going to really need to know is some stuff that you're probably already slightly familiar with. You're going to learn how to append. Appending, like in a list, is just like it is in a data frame, where rather than it goes on the end of the list, the rows are going to go at the bottom of the file or the data frame. Concatenation is about merging two data frames together. And lastly, we're going to show you how to do some replacement values. So that way you say, okay, well, anything above 1 million in my data frame is probably erroneous data in some way. So let's just change that to a 0 or, an empty value or something like that. Okay, guys, with that, we're going to now hop into our syntax section. And I'm going to show you how some of these commands work. So the first thing you see here is we're importing pandas, just like we've done for the past couple of sections. We are renaming pandas as PD, so it's easier for us to do like smaller calls like that. So if we didn't have this as PD here, we could just write pandas, and this would work just fine. Remember this line is how to load in a CSV file. We used pathing in our example last section, where I actually showed you how to go from your home directory all the way down into where this file actually is. And you'll see in this example that I've made a duplicate data frame. I have made one data frame called data frame and another one called data frame 2, and that's mostly to just illustrate later on in this syntax how we're gonna merge these two data frames together using concatenation. Okay, so the first command I'm going to show you is the head command. What head does is it gives you the top n amount of rows so that you can kind of just like preview what your data is looking like. You can put a parameter in here to tell it how many rows you want it to return, but I think default it returns 10 if memory serves. It might return like 5 or something like that. Regardless, this will give you a preview of your top X amount of rows. You can also do .tail, which is the exact same command, except rather than the top rows, it's going to give you the bottom. So it's usually nice to like check your data when you first load it by both looking at the head and the tail to make sure that everything is consistent and there's no like weird stuff going on with rows later on. Okay. What I'm showing you here is what the data frame looks like, or at least the preview of it with head. I'm showing you 5 rows here. It's similar to what we did last time, but I want to show you this because it's useful for illustration when I'm talking about this next function, which is called replace. So we have a data frame, and let's say we found that there was a couple of inaccuracies or in our data collection, or we need to replace some values, and we want to do that as easily as we can. So we use the .replace function for our data frame. You'll notice that .replace is delineated by a comma, and you have 2 sets of lists here. So what this is saying is I want to replace these values, the value 125 and 250, anywhere in the data frame. You can have it go to a specific column if you want, or call to a specific column. But for now, we're saying in the entire data frame, if you encounter the number 125, I want you to replace 125 with 130. And if you encounter the number 250 anywhere, I want you to replace that 250 with the number 225. Now you can have it replace, it doesn't have to be integer to integer, so you can replace it with a string, for instance, or a float, what have you. But the point is that you use the .replace, you have this comma, which delineates between the values that it's looking for and the values that it wants to replace. And if you have more than one value, you wrap it in a list. So, and then 125 is going to relate to 130, and 250 is going to relate to 225. Okay, that's how the replace function works in Pandas. Next, you remember that we use this .location function to say, like, I wanted, the first 3 rows in this specific column. What I'm showing you here is a conditional statement with .location, where you can say, I want all rows and all columns where the age of the person is at least 20 years old. So it wouldn't show John, and it would show Michael actually in this case, because 20 is greater than, because it is greater than. Consequently, you can also use the location function and create multiple conditions in order for in order for it to look through. So if you wanted to know, like, I wanted people that are over 20 and have a certain weight range. How you would do that is you have your dot location function, which is wrapped in these square quotes here, and you'll notice this ampersand sign here. That's saying that we have one condition here and another condition here that it's going to be looking for. The first one is similar to what we were looking at above, which was age greater than 20. You notice that I've wrapped this in just regular braces here. It's just a way to assure that Python is evaluating this logical statement separate from this logical statement. There's no weirdness going on. So you notice that I also have the quotes wrapped around here, and then this the condition statement is also double quoted at the end, and then the square braces are ending off the dot location function. And this extra conditional statement is now saying I also only want rows where their weight is either 100 or 150. So you're seeing this dot is in function or dot in feature, and that's just like, you know, it is 5 in a list. That's essentially, remember how we use the in commands for other things? That's essentially what it's doing here. So this should only show you rows where people are over 20 years old and have a weight of 100 or 150. And we'll see how that looks when we run this code later, okay? Next, we have the dot append function. This is just adding rows to our data frame. So I'm saying here just like add rows 1 to 3 to our current data frame here, and it's really that simple. In order for the append to work, usually you want to make sure that you give it all of the rows, all of the values that it needs for a row. Otherwise, if you don't, like, some values are going to return as not a number for some cells. So it's important that when you're appending complete information. If we wanted to rename columns, how we do that is using the dot rename function. So we have dot rename and these regular braces, and we say columns equals, and we provided a dictionary. And this is what the key value pair is, what the column currently is and what we want the column to change to. And you notice this is a dictionary, so we can have multiple values here. We can change weight and name too by just adding a column and providing another key value pair. So in this example, the df.rename is going to change age here to score, and then we'd have to like reference it accordingly. Lastly, if you were to, well, not lastly, but if you were to have two data frames that you wanted to put together because they were from like two different sources, or, you know, 2 different days, what have you, you can load both of those data frames together, load both of those data frames into variables like we did here with df and df2. We then use the pandas.concatenate function, and we pass it a list with the data frames that we want to concatenate together. So this will then give us, you know, this information here, and then it'll be replicated for df2, which will still have Michael and so on, but it's going to be added on together. Why? Because df2 is really just the same data frame, and I just wanted to show you how to like chunk on pieces of data on top of each other. Second last function here is, remember how we have, sometimes we have those NaN numbers? That's when a cell is empty. That means not a number. If you don't want not a numbers and you wanted to replace not a numbers with something else, I'm saying in this case replace not a numbers with 0. That's how you would do it here. It will look through the entire data frame and replace all not a numbers with 0. And then lastly, this last command is how to export your data frame as a CSV. And it's really quite simple. Remember how we had pandas.read_CSV and we gave it a name? All we do in this case is we say data frame object to CSV, and then we give it the CSV path. We can, if we give it just this path here, it's going to load into our current directory, but we can give it a path so that it will load into other directories as well. Okay guys, with that, let's hop into terminal and start playing around with this information a bit, okay? Alright everyone, here we are. So I'm going to go into Python right now. I'm in my root directory, so I'm going to show you how to path properly once we get to reading in the CSV file. First off, we need to import Pandas, so we do that with our import syntax. Import, then the name of the package, and I'm going to rename this package to PD so it's a little bit easier for us to write and do stuff with. So first off, we're going to create a data frame. So data frame is the name of our variable. We use the equal sign operator. We're calling our pandas library, and we're asking it to give us its read CSV function. I just pressed tab there and it actually autocomplete for me. If I just have read C, it'll show you the other things that are available to it. So you can read from clipboard too, which is kind of neat. So we're going to give it the path. Because I am not in the directory where this CSV file is. I know where it is though. It's going to be in my desktop. I'm going to go to Udemy, Python, scripts. You should find where your folders are as well. And then it was testdata.csv. We're going to close that brace, and that definitely worked. Okay, so we're going to create another data frame, so we use the concatenation thing later on. So I'm just going to store that in there for now. So first thing I want to show you guys is that head and tail function. So first, if we go df head, it's going to give us the first 5 rows. So the default is in Python to give the first 5 rows if you don't pass any variables in. df.head of 2 is going to give you the first 2 rows, the top 2 rows. So that indeed works as we expected it to, and this looks very similar to our syntax previously. If we do df.tail, it's going to give us the bottom 5 rows. Now this is a 7-row file, so it gets to the bottom of 6 and then goes all the way up. So that's how you look at both the top and bottom of your data. This is really useful when you first load in your information and you want to make sure that all the formatting is there and you loaded it in right, or there isn't any issues with the data itself. This is a great way to just preview that information. Okay, so let's just print that data frame there, look at it there. So first what we want to do is we're going to try and replace some values. So we use the df.replace function, just like it was in a list, but rather than replacing, one value, we want to replace a set of values. So the first object that we pass into it is a list of the values that we want to actually be replaced, and then we give it a list of what we want those values to be replaced with. So in this case, we wanted to replace the number 125 and 250 with 130 and 225, okay? So how this works is just like in our syntax. This is the value we want to replace, and then this next one, 130, is what we want to replace it with. And this is looking through the entire data frame right now. If we could give more specifics and say, oh, we only want like people with certain age to replace these values with, or something to that effect. So when we do that, what do we have here? We see that 130 has been replaced, or 125 has been replaced with 130, and 225 has been replaced by 250, okay? We do notice, though, that this didn't save. It just, changed the number. So if we wanted to adjust this and store the results in our data frame, we would have to do the dot, pass it back into the object right there. So let's go over the location function. I'm going to just show you the more complex one because we looked at that a little bit earlier. So first, if we wanted to only get values that were, for people that were at least age 20 or something like that, we go location, we wrap it in these regular braces. We say we want age, and we are giving the condition that age must be greater than 20. And because we want to give another parameter, we're going to give df, well, first we have to wrap it in regular braces, df weight, and that will be, we want it dot is in 100. So we only want people that are 100 pounds in this example here. Okay, so what happens when we do this? Oh, had a little bit of an issue. So what happened here? Let's see, it's saying you pass an integer in the is in. That's because we need to, pass it a list, right? Yeah, it needs to be a list, not an integer. There we go. And that's because it was looking for that. It needs a list for that to work. I'm now going to show you how to do the append. So df.append. So first we wanted to append just like the first 3 lines. That's what this looks like, or first 2 lines. So that's what that looks like there. So df.append df of 1 to 3. And then this should add a row, 2 rows to the bottom of our data frame. It indeed did there. Does it save it? No, it doesn't. So remember, you have to save that object if you want it to work. I'm going to show you the rename function now, df.rename. And that is, we go columns equals, and we give it a key value pair. So the key is the actual column, and the value is score. And because we have, we can do multiple columns with that. Oop. What did we miss? Oh, we missed that there. There we go. And so now score has been replaced with age, but it doesn't save. We have to make sure we save that if we want it to work. The last 2 things I'm going to show you are the concatenate. So with concatenate, we call pandas and go concat. We give it this function, and we provide to it a list of data frames that we want to be concatenated together. And you see there we have kind of a replication because there's 2 data frames here, right? And that doesn't save as well. We don't have any filling in of numbers here, so we don't have to worry about that. The last thing I'm going to show you is how to save your CSV file. So you take a data frame, you go dataframe.toCSV as opposed to read CSV, and then you give it the path that you want it to be saved to. So I'm going to save it back where the other stuff was. Desktop, Udemy, Python, scripts, and it's new CSV.csv. And that actually saved it, so you can go into your folder and check that for yourself. Okay guys, let's just wrap up here. What did we learn today? We learned some more advanced functions with pandas. We learned how to append, concatenate, and replace data in data frames. We also learned a little bit more about advanced manipulation and slicing techniques and how to dump our data.